Let's see. Alright. Where I last left off, I was testing, oh, that was a lovely noise, testing the circuit. Specifically, this part, power test. And, well, power test failed. So then I actually had to stop at that point. But I was going to then move on to continuity check. So I had to look up how to do that. And this is my multimeter. I've got it red jack in the all of these things port. Pretty much everything except for the 10 amp port. And the black one in the comm, of course, and then my dial set to capacitance and ohms and that little symbol right there, which means continuity check. And that is the continuity setting. Continuity in this is really nice. It will beep. It's not all the best, but I wonder if these come off at all. They move. Oh, yes. I mean, it's really nice to have a cap on to make sure you're not checking. I did not notice that before. That's really cool. These plastic guys come off and make life easier for when you actually need more length. Alright. Good to know. Okay, so continuity check. I had to look up how to do it, and I realized a couple things. Let's see here. Parts. One thing I'm gonna do is check what things have continuity on their own, so that I know that if I test one of these guys for continuity and it doesn't have continuity, uh-oh, did I lose a diode? Did I ever pick that up? Oh dear. Oh my. I don't know if I had to install a diode yet, and I appear to be missing. Oh no, I found it. Thank goodness. I'm gonna just attach this on here. Do not want a repeat of that. Just chill out on this. Okay. I'll check that out too. Why the fuck not? Alright, so to determine which things ought to be beeping in the first place and what things ought not to be beeping, I'm gonna check these first. So that I know how this works, kind of. Let me put this up. Okay, so capacitors. Does a capacitor on its own have continuity? No. So that means that anything like between this one and this one is too bright to see over there. Oh well. Anything between those two is not gonna give me any reading here. So that's good to know what components are actually going to give you a reading, so that you don't have to worry about trying to resolder those things, or even just, you know, reheat them when they don't have continuity on their own, so we don't have to worry about it. Apparently, capacitors do not have continuity. And again, I will say that I have never done circuitry work before. I've never done soldering before, as you can tell, but that one right there, the ugliest motherfucker in there. So, and then of course, let me check one of these. Diode here. We got one side. We got the other. No? Resistor should. I've got it in the right mode. Let me check. There we go. So, I guess diode. It's not giving me any continuity reading. I don't actually have any diodes on the board right now, so I don't have to worry about it. But I thought that these I suppose it depends on what the resistance is. How about this low one here? Well, I'm getting a reading. So, I mean, a reading is what I would be looking for. Okay, so 100. I get a reading on 100. I don't get one on the 330 and higher. So 100 ohms is giving me a reading, but not not the 330. Okay. Alright. So, if it's a low enough resistance, then I'd be good. So what I would want to check, I suppose, here, what I want to check then is that all these things are connected when they're supposed to be connected. And so for this capacitor, if I touch this side, And this side, I shouldn't get anything. Let me put it like this. Okay. So, unless there's like a connection on the actual circuit board, like from the green part to the green part, this won't beep unless I've got it fucked up in the middle there. So, getting nothing, so that's reasonable. However, in order to check the continuity of the actual capacitor itself with other parts of the circuit, I'm going to touch up on the lead itself and then touch another thing. And we've got continuity between this side and this particular thing. I can actually touch this to all the way over here. Yeah, and that'll give me a reading as well. So I'm not going to get a reading in between these two, just straight up, so that's reasonable. So instead of touching the solder point, I'm touching the lead itself and going from there. And then follow the traces. Try to only touch one of these sides. Let me try it like this. It's more likely I'm going to touch something else that I don't want to, but we'll see how this goes. It might make this a little bit easier for me. Let me put those in there. Okay, so we're going to test this side of the capacitor. You know what? I'm going to do everybody a favor and mark down what has proper continuity and what. I'm gonna just check like this. This is good. Let me see if I can find a place. Nope. Isn't there? There is. Okay, here in the back is a schematic. And that's actually pretty handy. Schematic says all kinds of fun stuff. Alright, so you have to understand what these different symbols mean, but I can kind of extrapolate a little bit and understand what exactly I'm doing. I can also refer to the instructions to find out what this is in particular. So this is this side. Yeah. So it's upside down. I got something in my eye. Okay, so we'll look at it like, oh damn it, it's like mirror image. Alright, well, okay. We'll just remember that it's the opposite way. So, we've got, well, let's do this in order. Fat. Hey. That looks like a discontinuity right there. Shebang. Alright. I don't know how to read these either. Let's see. I don't... Get off of there. I don't know. That thing is kind of iffy. This got bubbled up when I was working on it. I would be tempted to say that, no, I don't remember what it looks like underneath here. Let me just try this. Okay. So. Okay. Those are separated. Okay. So that's interesting. Well, this thing is connected to all that stuff. This obviously is not. There. These ones are separate from the other ones. I don't know. I'll figure it out. Okay. Let's see. I do get continuity on that. For a moment, and then it stops. Don't be telling me you're gonna shut off. I think this thing is an auto shut off thing that doesn't understand that you're still using it. It's super cool. I think. Let me see. Okay. I think the problem right here on this one is that it actually popped up from the board. So I think I'll desolder that and move it just a little bit so that it isn't on this part where it popped up, and then I'll get good continuity on that. However, you know, I might as well draw a picture of this since I don't know exactly how to read this. I think, and I'm not sure. I think this is a ground symbol. Where did I put my phone? Well, I got my keyboard right here. I could, like... I gotta find my phone so I can look it up. I don't have it on me. No, I don't. Okay, hold on a second. Phone. Where you go? I don't remember where I put it. It's not on this table. What was I thinking? What was I thinking? What was I doing? Dicks. Ground symbol. That is what I was looking for. Okay. Alright. Okay. Get back over there. Okay. Now I'm looking for what is, let's see here, ground symbol circuit. Oh, ground, wait. Electrical symbols. Okay, earth ground. That is what that means. I'm not so bad at this. I am pretty bad at it, but I'm not so bad at it. I know what earth is. Okay, there's also a chassis ground, and a digital common ground, which is the first one is like a pitchfork and the other one's a triangle. So that indeed is a ground. So I guess I know this one's definitely a ground. It says it's a ground. Where'd it go? Oh no, it's part of that actually. Yeah, here we go. GND pad. It's a grounding thing. And I've got continuity between that pad and which is also bubbled up to fucking shit. But, I mean, I don't know, I don't have continuity between these two. How am I supposed to? I don't know, I bubbled that up something fierce. Oh, you know what? It would be helpful if I turned that back on. Okie dokie, here we go. Okay, so this one might be a little bit of a problem. It is just the ground one, but I don't want to risk not having a ground one. So I will try to the grounding pad. A grounding pad. Is, I suppose, connected to the other parts of the circuit. So I might, I'm gonna check. Okay, good. Even though it's pretty badly bubbled on this side, I assume that you just can't see that. But even though it's pretty badly bubbled under here, I'm still getting continuity from the ground pin to the board itself. So we are going to mark that as a success. And so that is this one. This one is good. Yeah, I'll just circle the ones that I do. And then this, oh shit, that's not the one that I just tested. No. no good if I fucking test something and, you know, mark off the wrong thing. This, I don't know what that means. Resistor, potentiometer, a Zener diode, light emitting diode. Haha, it's got arrows. That's pretty straightforward, I suppose. What would this be? I don't even know what this would be considered. It's just whatever. Okay, well. C43, that's this. This has a ground. This, I'm gonna assume this is this. I don't know what this, you know, if I'm gonna be learning what a circuit does, I might as well you know, figure out how the schematic works. It's got a little notch in it. That's what I'm questioning specifically. Earth ground. Capacitor. Electrolytic capacitor. Capacitor is used to store electrical charge. It acts as short circuit with AC and open circuit with DC. I suppose that's important to note. That's a good idea. Keep looking at this. Excuse me. Boop, 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 boop. I'm not seeing anything that would tell me why there's a little notch at the back here, but oh well, this, we'll just say, yeah, it's kind of connected in a roundabout way, but technically speaking, I should be able to touch this and then just kind of hop through the different, oh no, that's got continuity. Okay, maybe I don't have to resolder that one. It kind of looked a little iffy, but okay. These are good. I guess I will just circle this. That one, and this connection, and this connection, and the connection to this. And the ground, and the ground, well, I suppose, well, one way or another, it's touching that. You know what, technically speaking, this could be popped up so bad that it's not. No, that's right on it. Never mind, I'm crazy. Maybe. I don't even know. I don't like that it's bubbled out like that. Anyway, that goes into whatever. It connects all these. Huh? Here? I would help if I'm on. Okay. We got connection. You know, it could actually be. If I touch it, it solder points. Eh, well. Okay. Those two are definitely connected. See, no? No, those are good. Okay. Those two are connected. This on this side. What is on the other side here? That's this. That's half of this connected to further down the line. Stop bending these things. Eek. Okay, and so these two don't appear to be connected. It's because it's one of those guys. So that's as expected. But this should be connected to other things around it. This is a capacitor. Yeah. This capacitor is connected on that side, and it appears to be connected on the other side as well. Let's see. Okay, let me take a look at this side. What's going on over here? That's a test point. Then it goes down to another capacitor. So I should get continuity between that guy and that guy. Like this. If I don't touch them. And I do. And that is good. It's further down here. Okay. Okay. So that is indeed that. I have connection to the test point 1, which is that little nubby guy right there. I also have connection to that side of that capacitor. Here. And then the other side of it is connected to that resistor. And I can check it like this too. And I get it on both sides. So we've got both sides as well as that ground. So we're good here. This is a tiny part. This, oh, thank goodness, that tells me exactly how that's doing. Okay, so we've got this side, the one here, will be connected, obviously, to either this or the test point as well, I suppose, or that, and we are good. So we've got this one connects with this one. Okay. Inside here. So we've got this. Actually, let me try doing this. I'll circle it here and here. Okay. And then this one goes out to the ground, which is straight up like that. Good. And that one just stops there, I suppose. And then this one on the bottom here, apart from connecting with this one, should not connect with anything else, which it does not. So that is a success. I'm going to circle that one as well now. Let's see. Next, this guy, obviously, these two. Oh no. They do connect? No, I didn't think so. I mean, hush you. I'm still using you. Okay. False positive? Maybe I was touching something else. Fuck if I know. Okay, so, whatever. Anyway, this one up here should also not connect to anything. No one connects with this one, which is also a ground, and that's acceptable. So these two technically do connect because they both connect to the ground. It does not connect with any of those. So nothing, nothing. What? This has got really nice sensitivity. It's a little iffy, but it's got good sensitivity. Okay, so these two should definitely. Okay, so okay, this one is acceptable as well, and it is grounded, and it connects technically with that one via the ground, but we're not gonna do anything about that. And then what is this? Number 6 over here, which is this one right here, connects with, I'm just gonna touch the lead of the capacitor there. That, which is stuff. I think this right here is this. I didn't get any instructions for any connection going in here just yet, so that's fine, I suppose. Connects with this side of the capacitor, so from here to here, which is working. Let me circle that. this one right here. And then this connects to the ground, which is this pad here. It's a grounding pad. I don't know if anything connects with that, but it definitely connects, so that's good. There's a ground pad. And then, of course, also this side will connect with this side of the battery, which is that. So we good. That's the battery negative. Hush, hush. We got positive on this side, negative on this side. That is a battery negative. Just, I know it only goes on one way, but it's always good to ascertain the proper whatever. Okay, so rather than doing more stuff down here, I'm going to come back to this. In any case that is successful, it also should not touch anything else, technically speaking, unless potentially, I mean, I think, no, there's not a ground in there. Why is this? I suppose it splits. It splits. And then it splits again, I suppose. Yeah, that makes sense. Okay. So this one right here should not connect to any of the other test points. Not test points. Soldering joints. It connects to the ground. I think I'm accidentally touching that one, which does connect to the ground. So yeah, that one's good. Now we're gonna go take a look at this one, which comes out the top of it here. And it connects to this jumper. So this one, is that the one? Yeah, that's the one I'm looking at right here. Connects to here. This one? Yeah, this one. Connects to that. Connects to that. Which is the jumper, and physically I can tell it connects with that one. Which is... This is successful. And... now that's a capacitor. I got that capacitor here. Excuse me. And then from here to here, which is into this. And so on. And does it connect to anything else? Nope, just to that. That one comes in here. And that one, actually, let me test. Nah, did I already do this? It doesn't connect to anything else. Or it should not connect to anything else. Okay, so yeah. We already tested that this next one connects to the ground. It also connects to that other one that connects to the ground. Okay, so that is good. It connects to the one that's also grounded, but otherwise it does not connect to any of the others. Stop that. So, that one is indeed good. Both. And this one comes around. This one's the very last one here. Comes around and goes through R44, which is the resistor. And that's good. I don't get a connection there, but I don't know. Huh? I thought I got some a little bit of a reading. That is a resistor though. And their job is to resist. I'll circle over here. I did get some reading on that resistor itself. Let me just do this. Yeah, I'm not gonna get a beep from that, but it does give me a reading, so that's good. I accept that. Alright. Okay. And then this resistor, which is itself, it has good integrity. And this side of it here, with the capacitor, and then obviously it won't get through that. Yeah, whatever, good enough. And then this one, which is the other side of the capacitor, comes back in and connects to this guy, which it does. Then I could even touch these and it won't do anything with that. Okay, so that successfully connects to this. That one has nothing going on here except for the capacitor, right? No, looking at the wrong side. This guy doesn't connect to anything at all, not even the ground. Nada. So that just is a pointless little hole. This indeed does connect and not connect in the proper proportions. So all this is good. All that's good. Okay. To my knowledge, these, they beep. They say it's okay. Alright, so that's all this stuff. What's next? This awful mess right there is just, terrible. Alright, let's try this one to this one. Yep. Not touch that. It's the on and the off, and the volume, which is all one. Okay. Let's see here. We've got, that's itself is a resistor. I forget. There's this side of it, a ground, 2 points. I've got three points on the one side. And Hold on a second. No, yeah, it says cut off locating pin. And it points to that little guy right there. It says cut it off. I cut it off. I'm assuming I followed the directions correctly. Okay. So far we're good. Oh, you stop it. I'm still using you. Okay. So far, everything's, tested out as I would expect. And there is the capacitor over here, which does not. Boop. I'm gonna circle that. Okay, so, I've got we've got a ground. I think this is itching my face. Knocking shit around. Okay. This capacitor on this side also connects to that, which is this. And then, if it's closed, if the circuit is closed, it'll be connected to the positive. This one right here. This one should be continuous with the negative. So that's successful. I'm gonna say, yeah, this is connected to this side, which is this guy. And it's also connected to the positive if the circuit is closed. So technically I should be able to touch these. But the circuit is open. Oh. So that's how that works. Okay. So, let's take a look at this other stuff, I suppose. This one, it's not this one. That one doesn't look all the best, but this is a ground. Oh, I don't see. Let me go from the other components inward. That would probably help me out. Which is 2 capacitors on that side. Here's one of them. You know what? Did I circle the wrong one? This is this lower one. And that is continuous. This comes out to the jumper. No, I already checked that, I guess. This other one, these two on that side. I forget, you can just do this. These two are connected. Are they supposed to be connected? This one comes up along here. This one, I don't think they should be connected. I think that might be the problem. These two. Yeah, it looks like it's maybe. I don't know, let me. Of course, where did I put it? Okay. Take a closer look in here. It's possible that those two get bridged, and that's why it's not happy. I'll take a look at that. I think that might be a problem, because I don't think those should connect unless they're connecting inside the device, and honestly, I don't know. But so these guys connect, and I don't know if they should. Okay, so I think well, maybe I should check this from the bottom, hey? Because just because the tops work, well, of course they work. They're connected up here. I should check between this one and this one. Okay. So yeah, that's good. Whee! Okay. And so we got this from well, that and that connect, and then this and this, no, this and this. Yeah, is that one a problem, or is that another problem? Or alright. Taking a look at it from the top down here. I can look at it normal now. Okay, so this test point 2 should connect to this, and it does. Should technically connect to this, and it does give me a reading, so I will give that an acceptable mark. It connects to something else, but we haven't done that yet. This thing, which I guess switches to AM and FM. That might be the switch. So I'm gonna leave that unchecked, but I am gonna circle this side of it. And I'm gonna circle this side of it. And this side here should connect to this side. Yeah, okay. We good here? We're good from here to here. We're good from here to here. From here to here. I don't think... No, I guess maybe these two. That's what it's resisting across. Here's that ground symbol. So this one should be grounded. And I don't think these two... Stop that. I do not think these two should allow themselves to be connected. Not getting a reading at the moment. This and this? How are those connected? Am I touching something else? Or I was touching something else. No. Oh yeah, it's on in the on position right now. Alright. Well, okay. This one I already checked. Connects. Down the line to this. Okay. I think... Whoops. I think that's everything that I soldered. And I touched something I thought that was connecting that I didn't think should be connecting, but it might. I'm gonna draw a couple lines here to represent where these things are actually connecting in. And when this is open, I get a connection between these two. I should be getting a connection between these two. No? I turned off the multimeter. That would be why then. Connection between those two. I already checked that. Actually, which one of these is the ground? Or it says it goes to ground. This is the top one. This one right here connects ground. Gonna circle that. And, I mean, technically speaking, I could be getting a reading between these two. I thought I was getting a reading between those two the last time, but maybe not. Let me close it and see if that changes it. Okay. So if the circuit is open, if this circuit is open, nothing. If it's closed, something. So, okay. I think that's everything, actually. So, despite the, absolutely disgusting looking connection on some of these just bubbled away from the board in a couple places, and that one I murdered that thing. Just terrible. Despite all of that, so far it works. In theory, it works. Now, in practice, having a little bit of trouble. We're gonna try the power test again. Let's see. Dynamic measurements. Power test right there. Okay. Power test. Here it is. Here's this. Which, I mean, let me look up how to test a battery. Test. I could even do this. Battery with multimeter. Is that funny? I thought I understood what it was. Check a car battery. You have to use a multi. Wait, I don't want to watch a video. Check a battery using a multimeter. Blah blah blah. Multimeter. It says an alkaline battery. That says alkaline battery on it. Oh my god, Christmas music, no. I'm listening to music as I do this. Do not want to listen to Silver Bells right now, but it came on. I've got it on completely random. I have a very large music library, so it's pretty big. To test the battery, turn on your voltmeter. Switch DC volts. They're touching each other over there, aren't they? That's amps. I hate it when my nose starts leaking. Alright, so volts DC. I don't know why it's measuring. Apparently, shaking them around makes there be a charge, which I suppose that makes sense. Okay, and then Which side is the plus side? I always forget. Here's the plus side. This is the negative. This is a positive. What does it say? Black to this one. 9.39. It's stabilized too. So the battery works. That's good. Well, now I know how to check my batteries. I have a fuck ton of batteries in a box downstairs that's just they've just been collecting there because I use it and then take it out of something and then don't know if it's a good battery or not, so there's probably some good batteries in there that just haven't been used before. So I'm gonna turn that off. By the way, if you get one of these X-Deck instruments, fuck, I don't even remember. X-Tech Mini Multimeter Model EX330. This, if you get it, take off that thingy. And it stays on the table, and it doesn't spin around. I was pretty happy when I realized that. So, we're gonna try this again. We're gonna try this again and hope for a little bit better stuff. I'm gonna close the circuit here. Excuse me. Open the circuit. I'm gonna see if I can get this battery in at all because it's like fucking impossible. Like this clip, yeah, it's lovely, but man, how the hell are you supposed to get something in here? Maybe push it back? Dude, that thing is just gonna snap. Fuck it, man. Alright. Okay. We're gonna try that. Yeah. Boop. My nose just seriously starts leaking. I'm pretty sure there's like a hole in my brain thingy. Alright, so what does this say? Again, I'm ignoring that line bullshit because fuck that. The thing with measuring voltage is you gotta get in the circuit. So we're gonna, what do you say? Switch it to DC amps. DC amps. This over here shows DC amps. Set it to read 2 amps DC. That go. We're gonna take that out. We'll switch it to microamps. Just for starters. You know what? I don't need this in the 10 amp thing. I'm not gonna get up as high as 10 amps. If that's the problem I was having before, that I simply was in one of these other things, that's good idea. Don't pull this out when it's on, probably. I don't know if I just did that earlier, but probably don't pull these out when they're on. I got it on that. I'll just do micro, milliamps, milliamps. Okay. And then touch. That one looks like the black one. Yep, black one. To this. And this one to this one. Like that. And drum roll. Turn it on. Oh, yeah. I'm gonna just pull my sleeve up so that I don't know. Whatever. Okay, so okay. If the current is greater than 20 milliamps, immediately turn the power off. Current should be less than 10 milliamps. What we got? 2. Even in the highest on position, 2.7. The current should be less than 10 milliamps. This current is drawn by the battery when no input signal is present. The idle current. Turn off the power. If your circuit fails this test, check all the parts have been installed correctly and check for shorts or poor solder connections. So even though I have some really ridiculously dumb, shitty looking solder connections, this still works. I think the problem before was I was trying to bullshit with this motherfucker. Fuck that wire. Don't, if you ever get this kit, disregard that. Just shove the battery in there and you'll be good. Fuck. Oh, okay, I still need it in though. Now I said put it into the holder, so let's try and get this in now. Ah, that thing is just gonna snap, man. Also, damn, this thing is just tight. It's very tight. Tight like a tiger. Shit. Pop it out, pop it out. Ah! Ow. Also, I'm gonna do this even before I connect to anything. Everything's good. I tested it. Everything's good. I understand it now. I even went over the schematic. Checked everything. Everything's beautiful. I'm getting rid of these. We'll put these in there. This will be my garbage. Ah, it's Alt. Control. This one's delete. We're gonna put it in the delete cup because I'm silly. That one. Oh, I can turn this off. This one should be the control cup. Musical cups. None of this matters. But when you get the urge to do something and you feel like, hey, I want to do this, just do it. Do it. As long as you're not hurting anybody. Get in there. Get in there. Get in there. Don't ask me why I just did that, because it was completely and utterly pointless. Alright. Maybe I can even get a little closer. These clippers came with my soldering iron, and I gotta say, good purchase. It does say to clip off the excess here. Where does it say that? Here. No. Here we go. Solder and cut off excess leads. They're thick, but you know, of all the joints, ooh, that's a snap. Ooh. Hell, I don't even need to cut off the excess. Of what? Oh, that damaged that. Oh yeah, that damaged that. Thick. Yeah. I forgot what I was saying. It was fun. I noticed while I was soldering these guys, my soldering iron kept sticking to the magnet. Not necessarily a good thing. Perhaps another part of what was wrong before, if it wasn't that, was maybe these excess leads were touching other things. It can happen. I think what I was saying was this, well, my mind at least went there. I was thinking my most proud solder joint. That looks pretty decent right there. Actually, there's another one. That one looks really nice too. I just kind of said fuck it and soldered two together because they're a connected pad anyway. But overall, I'm pretty happy it works. Okay. Let's get out of here. That's pretty much everything. All the pokey bits. And despite that they're, you know, kind of ugly looking, still works. Get off there. So I'm satisfied. Little iffy. Oh, that wasn't a good sound at all. That ripped off. I'm gonna redo that one. Yeah. Let me turn this on. Get my little fan going. Yeah. Be careful that you don't rip up solder connections when you clip off the excess leads. Sorry. I took out the battery completely, so it's not live right now. Oh, where did I put that? It's right there. Yay. Hell, I don't even know if I'll have enough for the rest of the board if I keep going through it as fast as I'm going through it. There's a tiny amount left. I don't know. I think there was a lot more than that, but alright, I might not need that necessarily. Oh yeah. I tinned it. Clean that off. Yeah. Alright, I do have a flux pen here. It's a little hard to get a reasonable amount of flux on here. Just kind of like splooshes. We'll see. Oh, that's drying off right away. I don't understand. I'm gonna make sure that this is still continuous. Yeah. And then from here to here. Okay. That is all I need to know. Okay. I don't need this. Okay. So. Fix the thing I fucked up. That's, yeah. Okay. And I'm gonna put the battery in. You, based on your personal preference, you may find that a vice grip type situation would be helpful for your board holding purposes. Some of the reviews, or not reviews in particular, but some things that I looked up said, don't bother. Alright, connected. I'm gonna pop this in. That battery will never come out again. Just kidding. This is a very strong clip. I'm worried that it's gonna snap, but I mean, I guess it's gotta keep it in place. You can shake your radio as much as you like, and it'll be fine. All right, now this second test. Is from the front, like this. Well, they designed it the wrong way. Kidding. Okay. The label doesn't match up with the text. I need this again. Put this off to the side. Do that. And what are we doing this time? Volts / ohms, and we're gonna switch it to output bias test. Put the battery into the holder. Adjust your volt ohm meter to read 9 volts and connect it as shown in figure 7, which is not particularly visible. Oh well. And then whoop. DC volts. Beep beep. Okay. Adjust this to make sure that the battery or a 9-volt power supply, if available, is properly connected and the power turned on. Let me read that one more time. Adjust your volt ohm meter to read 9 volts and connect it as shown in figure 7. Ground. Test point 15. I don't know what I thought I heard the speaker make a noise. Make sure that the battery or a 9-volt power supply, if available, is properly connected and the power turned on. The voltage at test point 1. This test point 2, test point 1. I don't know where to ground this. We'll ground it on test point 15. Okay. Ground it. Ground it. Ground it. Ground it. Like, get in the hole. Get in the hole. There we go. Okay. Grounded on test point 15. Number 1 should read between 3 to 6 volts, which now it is 0.455. Okay. And if you get this reading, go on to the next test. If your circuit fails this test, it doesn't say anything about test point 2. Test point 1. I'm getting 0.4. Get on there, bitch. There we go. 0.443. Black one ground like this, and that one. I don't know. I'm getting consistently 0.435 volts, which, I don't know. Let me compare it to the battery alone. Hold on. If you get this reading, go on to the next test. If your circuit fails this test, turn the power off. Good idea. And check that the integrated circuit is correctly inserted in the correct location. The notch of the IC must be in the same direction as marked on the PC board. Check that all resistor values are the correct value and not interchanged. All static tests must pass before proceeding to the dynamic tests for the next section. I do not have a generator. I do not have an audio generator, nor do I have, where does it say? Oscilloscope. I don't have that. you know, it'd be cool to do that, but I don't think so. Transistor audio amplifier is the next section. So I don't have, if you do not have an audio generator, skip the following test and go directly to section 1B. I'm gonna do that, but first I'm gonna take the battery out. Very, very carefully. I hope that it doesn't explode on me. Damn, man, this thing is fucking in there. I have tweezers and shit. Let me get some of this stuff out of here. What's this? Exacto knife. Tweezers. They go here. Gonna leave that in there. As well as this. It also, the multimeter came with a temperature probe. So, that was pretty cool. Okay. We're gonna take a look at this. If I could just get it out of here. Don't wanna damage anything. Don't particularly wanna damage anything. Let me put that off to the side. And unsheathe all my tweezers. Whatever. Organization is key. Hey, you know what? I miss Third Rock from the Sun. That one's got a flat end. That's interesting. Ooh, that one's got nice width on it. These, I didn't look at them too terribly closely, but they've got some nice different features on these different tweezers. I was thinking, you know, I shouldn't need more than one set of tweezers, but no, it's actually pretty useful to have a whole set like this. So it's pretty nice. It's got a nice real thin one, all kinds of different sizes and stuff, so whatever. We are messing around right now. I guess that's what I'm doing. Alright, I'm gonna stop fucking around. Trying to get the battery out. Not gonna use the Exacto knife. That sounds like a bad idea. Ah, man, this fucking thing. That one's got some beef to it. Pop this out. We will pop this out. No, we won't. Uh, why am I having such difficulty with this? Come on, man. I don't want to fucking break everything. Meh. Breaking my nails over here. Haha! Ha! No! Damn it! Son of a bitch. Okay. Get that under there. And then... Yay! Success. Fucking spring loaded. But alright. Okie dokie. So, yeah. One more try. Nine volt. So I was getting 0.4 volts here. Oh, excuse me. Let us check that I did all this shit correctly. Blah de blah de blah. Blah de blah de blah. Okie dokie. Let me read it again. It says between 3 and 6. 43. 100 ohm is brown, black, brown, gold. Brown, black, brown, gold. C42. Yeah. Those are all capacitors. 10 ohm resistor. Brown, black, black, gold. Brown, black, black, gold. And the other one. And the other one. There. R44, yellow, violet, black, gold. Yellow, violet, black, gold. Those are right. And the capacitors. C42, 10 micro, 10 micro. Does also goes with 10 micro. And the 470. This one is 470. And the one on the back is 470. Oh, okay. It says I should be getting between 3 and 6. Let's put this motherfucker back in here. Cause I'm definitely getting, that is hertz. Don't it? Get up here, some bitch. Okay, so .39 volts. And you know what? Try and cheat to make it easier to get it out next time. Maybe. We'll find out. Alright. Ground. Test 115. Test 1. 3.82. Okay. I don't know why it's working now. But it's working just fine now. Oh, I can hear that. In that. Ah, lovely. Lovely. Success. Iffy success, but success nonetheless. Turning this off. So we've got a working speaker. We've got a working circuit. I'm pretty happy right now. Yeah. There are, so far I can say about this kit, there's a few little iffy bits, but personally speaking, it is in my range of understanding and figuring out how to do things correctly. It's not a very thorough kit. I would suggest that it would go very well with an actual course, because you'd learn about these things in the course, as well as you'd learn about the components, as well as the schematic drawings and what those mean, and the whole process. But for my own particular level of education and I guess ability to research things, this kit is very satisfactory. It's not so it's not too easy and it's not too hard. So, and I got it very specifically for practice, so it's alright. Check and check. I'm just gonna go ahead and do this. Heck, I could even write, like, whatever the value is. Whatever. Okay. Now we're doing this little guy. So, Section 1B, Transistor Audio Amplifier. Let me remove some of these things from my area over here. This, I'm actually going to set off to the side. I don't need it right now. If you have successfully completed the IC audio amplifier, you are now ready to build the 5-transistor audio amplifier. The transistor audio amplifier is built on a separate PC board and will plug into the IC socket. It will be necessary to remove the IC from its socket when the time comes. This little guy, that cute little fucker. That's a nice tiny little board. It's cute. The ratio of the power delivered to the speaker and the power taken from the battery is the efficiency of the amplifier. In a Class A amplifier, transistor on over entire cycle, the maximum theoretical efficiency is 0.5 or 50%, but in a Class B amplifier, transistor on for half cycle, the maximum theoretical efficiency is 0.785 or 78.5%. Since transistor characteristics are not ideal in a pure Class B amplifier, the transistors will introduce crossover distortion. This is due to the nonlinear transfer curve near zero current or cutoff. This type distortion is shown in figure 12. This type of distortion is shown in Figure 12. In order to eliminate crossover distortion and maximize efficiency, the transistors Q11 and Q12 of the audio amplifier circuit are biased on for slightly more than half the cycle, class AB. In other words, the transistors are working as class A amplifiers for very small levels of power to the speaker, but they slide toward class B operation at larger power levels. Transistor Q10 is a class A amplifier that drives Q11 and Q12 through the bias string R46, D5, and R49. Q13 and Q14 are current amplifiers that amplify the current of transistors Q11 and Q12. The AC and DC gain are set by the DC current in transistor Q11 and the collector resistor R46. The AC gain of the audio amplifier is approximately equal to 100, while the DC gain equals approximately 50. The transistors Q13 and Q14 self-bias so that the voltage at their emitters is approximately half the supply voltage. R47 provides feedback to the base of Q10, which is biased at approximately 0.7 volts. Capacitor C40 couples the audio signal from the volume control to the input of the audio amplifier. Capacitor C43 blocks the DC to the speaker while allowing the AC to pass. Okay. Assembly instructions! Yay! Be careful to properly mount and solder all components. Diodes, transistors, and electrolytic capacitors are polarized. Be sure to follow the instructions carefully so that they are not mounted backwards. Check the box when you have completed each installation. Wear safety goggles during all assembly stages in this manual. I've got my safety goggles on. Actually, I've got safety glasses on. So, yeah, okay. We'll put this off to the side over here. And we got this. Solder. Preheating the oven. Heating up my soldering iron, and it's already good to go. Okay, this has multiple test points. I don't need that, but I do need these. I'm gonna need this. I'm going to need more parts. Let's see, what have we got? C46. C46. It's a disc capacitor. That's what it says. I ain't got nothing. I mean, it's not there. This one right here. That little guy. That little guy right there. You're C46. There we go. straightening out the leads. $102. That's 10, and 2 is the second digit, right? Or no, that's the third digit. 0. Oh, don't. No. This. Multiplier. Yeah, okay. 0. 0 is the first. 2 is 100. So 10 times 100 is 1000. Or 1000. And 1000, the picofarads, or pico I don't know why they keep swapping these guys, but well, 1000 negative 10 to the negative 12. Yeah, it's a lot. You know, I think I'll take a break for a moment, since we successfully completed the previous section. So I'm pretty fucking happy about that, and I'll get these set up while not on camera, just to make it easier for editing later. So, good for now. Also, I want to make sure that my thing up there is not full.